Welcome back, smart mathematicians. Let's do question 11.2.1b. Right, I'm going to show you three alternative methods to prove this that the quadrilateral KLMN is a cyclic quad. Right, in the diagram, PK is a tangent to the circle at K. Chord LS is produced to P. Chord LS is produced to P. Then N and M are points on KP and SP respectively, such that MN is parallel to SK, chord KS and LN intersect at T. Prove giving reasons that KLMN is a cyclic quad. So we have to use our previous answer. Remember, in the previous question, we managed to prove that angle K4 is equal to angle NML. Remember that. We said this angle is equal to this angle. We have angle K4 being equal to angle S1 because of the tan chord theorem. And then angle S1 is equal to angle NML because since they are corresponding angles. You see, NM is parallel to SK. We want to prove that KLMN is a cyclic quad. So this is the quadrilateral that we're talking about. KLMN. Is it a cyclic quad? How do we prove that a quadrilateral is a cyclic quad? If the exterior angle is equal to the interior opposite angle, and also if the opposite interior angles add up to 180 degrees, or if the opposite interior angles are supplementary. We have to check those two first. And then now, if you look at this quadrilateral, you can see that K4, which is an exterior angle, is equal to the opposite interior angle, which is NML. So we're saying here, angle K4 is equal to angle NML. We proved that in what? In the previous question. So let's write proved. We can then conclude and say this is a cyclic quad because the exterior angle here, K4, is equal to the opposite interior angle. So therefore, KLMN is a cyclic quad. Is a cyclic quad since the exterior angle of quad is equal to opposite interior angle. Okay, so we say that KLMN is a cyclic quad. That's the first method. Now let's go to the second one. All right, for the second method, we're going to use the side of our tangent. Let's talk about angle N1 and angle NKS. You see that? Angle N1 and angle NKS, they are equal. Why are they equal? If you check, these are corresponding angles, isn't it? And then if you check, angle NKS and angle KLS are equal because of the tan chord theorem. We can also see that the exterior angle is equal to the opposite interior angle. Let's discuss that. So here we're saying angle N1 is equal to angle NKS. Angle N1 is equal to angle NKS. This is angle N1 is equal to angle NKS. This is angle NKS. They are corresponding angles since MN is parallel to SK, KS. Okay, right. And then if you check angle NKS is equal to angle KLS. Okay, this angle NKS is equal to angle KLS because of the tan chord theorem. And then now if you check, we're saying angle N1 is equal to angle NKS. which is equal to angle KLS, right? So therefore, angle N1 is equal to angle KLS. So therefore, angle N1 is equal to angle KLS. And then if we check, we're talking about this quadrilateral, which is KLMN. And then you can see that angle N1 is an exterior angle that is equal to the opposite interior angle. You see that? This angle, and this angle are equal. So it means we can conclude and say KLMN is a cyclic quad because the exterior angle is equal to the opposite interior angle. See that? Therefore, quadrilateral KLMN is a cyclic quad. Okay, and then the reason we say exterior angle of quad is equal to opposite interior angle. Okay, so it's a cyclic quad. Then let's do the last method, alternative method. Right, the third one, we are going to use the fact that K4 is equal to NML. We say this angle, we can find angle NKL in terms of angle K4. What can you say? This angle here, NKL, angle NKL is equal to 180 degrees minus angle K4. Why? Because these are adjacent angles on a straight line. So it means that if this one is 180 degrees minus angle K4, it means it's just the same as 180 degrees minus angle NML, because NML is equal to angle K4. So we can say it means therefore angle NKL is equal to 180 degrees minus NML. Since angle NML is what? Is equal to angle K4, right? We prove that angle K4 is equal to angle NML. We prove that. Proved. We can add these two angles. We say angle NKL plus angle NML. NKL, which is this, plus angle N, this is A, looks like a C, plus angle NML. You see that it will give us what? It will give us 180 degrees. So if we say angle NKL plus angle NML, you're getting what? 180 degrees minus NML, which is, this is the angle we're talking about here, and then plus this angle, this one, plus NML, angle NML, and then what do you get? We get that angle NKL plus angle NML is equal to 180 degrees. Do you see that the opposite interior angles are what? Are supplementary. The opposite interior angles are what? Are supplementary. So therefore, the quadrilateral KLMN is a cyclic quad. So this is a cyclic quad. Therefore, KLMN is a cyclic quad. Opposite interior angles supplementary. So that's how we can prove that this is a cyclic quad. So now we know that KLMN is a cyclic quad. So we're going to be using that for the next questions. We have proved that the quadrilateral KLMN is a cyclic quad. So we're going to be using that information in the next questions.